How many ordered pairs, x, y, satisfy the system of equations above? Alright, so when they say ordered pairs, that means just values of x and y that make the above equations true. That when you plug in the value for x and the value for y, you will make these equations true. So, in other words, if you actually were to graph these equations out, the ordered pairs would just be the points where both equations overlap or touch. Okay, and the way you can do this, if you want to know how many of them there are, because that's what the question is asking for, is to solve for one of the variables, isolate for one of them, and plug it into the other one, and then solve for the value of the other variable. So here they already isolated for both x and y for us. So let's take this y and plug it into this equation right here for that y. So let's try that out. So what that'll give us is x is equal to 2 times 2x minus 3 times x plus 9, all of that plus 5. Okay? So we're going to take what's on the inside here and FOIL that out. So how are we going to do that? Well, 2x times x, well, that's 2x squared. Then negative 3 times x, that's negative 3x. Then 2x times 9, well, that is plus 18x. Then 3 times 9, or negative 3 times 9, and that is negative 27. And we close all that with a 2, we multiply that by a 2, plus 5. Okay, now these guys right here, they simplify to, well, negative 3 plus 18, that gives us 15x. Okay, and now let me multiply the 2 throughout. Let me distribute that 2. So what I'm going to do is basically is 2 times this, 2 times that, 2 times that, and 2 times that, which in reality is just 2 times the 15x, since we combined the negative 3x into 18x. So what that's going to give us is 4x squared plus 30x, or rather, yes, 30x, because we're multiplying by the 15. Then minus 2 times negative 27, which is going to be negative 54. Okay, all of that plus 5. And if we add the negative 54 plus the 5, we will get 4x squared plus 30x minus 49. Now let's not forget, all of this is equal to x. So if we subtract x from both sides, because we want all this to be equal to 2, so then we can solve for x. So now we'll have 0 is equal to 4x squared plus 29x minus 49. Great. Now what do? This is where the boys are separated from the men. Either you know how to do this from here or you don't. What you want to remember is we want to use the discriminant. Whenever you want to find out how many ordered pairs are in a system or are in an equation, you want to use the discriminant. The discriminant, if you remember, is b squared minus 4ac. Okay? Where our a is 4, our b is 29, and our c is negative 49. So if you plug that in, our discriminant is going to give us what? It's going to give us 29 squared minus 4 times our a, which is another 4, times c, which is negative 49. Now, the thing with the discriminant is you don't actually need to calculate the actual value. I mean, thank God, because this is a no calculator section. But what you do need to do is know whether your discriminant is going to be a positive value, a negative value, or just 0. Because if it's positive, that means you will have 2 ordered pairs that satisfy the system. If it's 0, that means you'll have 1. And if it's a negative value, that means you'll have no ordered pairs that satisfy the system. In this case, we have 29 squared, which is a large positive, minus something times something times something that is negative. So essentially, it's going to be a positive plus another positive, right? Because negative times a negative is just a positive. So this whole thing is going to be positive, and therefore, the number of ordered pairs that satisfy this system of equations is just going to be 2. So it's a little long, but if you work throughout it and you know what you need to do and you know when you need to use the discriminant and you remember what the discriminant is, then it should be straightforward. With a little practice, you'll be able to get this down a lot easier.